Okay, so this is my recording for Lab 3. It's going to be the simulation section of of my demonstration. So essentially, I had to install, or not install, but move the file SysTick.c and SysTick.h into our Lab 3 folder. And after that, I just had to edit a function. So this was previously titled SysTick weight 10 ms. I just changed it to 500 ms because that's the equivalent of 0.5 seconds, which was the requirement for our delay in the Lab 3 worksheet. And essentially, the numbers I'm using here are based on a 16 megahertz clock because that's what the simulation is in. So the Texas grader runs it in 16 megahertz. So my calculation is based on that, just for testing purposes. Essentially, without this 50 here, 160,000 would be the equivalent of 10 milliseconds. However, if I multiply it by 50, of course, that equals 500 milliseconds, which, as I mentioned, is the equivalent of 0.5 seconds. So we could see that in my comments as well. Yeah, so that meant, because I did my calculation here in the function, that means I could just pass in a 1 for when I call SysTick wait. So this would be my delay call. I could just pass in a 1, which means it would do exactly what the function does without any extra calculation. Essentially, I is less than 1, and it'll just run through SysTick.wait, which is the function that came with the file. Okay, so to initialize it, I had to define the prototype before main, and of course also call the init. And I had to actually call it after initializing port A and port E because for some reason it wouldn't work unless the clocks were, I guess, defined before SysTick init was. But doing that did fix the problem I was having, and my code does seem to be working now. So if I quickly run the simulation, okay, here we are. So we're at the beginning, and if I run, so this is the run icon, and so first I hit south, it should go to green. It does. Flip it, click west, it goes to yellow to red real quick, and then I just basically I flip south on and west on at the same time, and it quickly cycles through all 3 of the LED choices. And there is a 0.5 second delay, and I could show that in just a second. So if I stop this, okay. So basically, to measure that my delay calculation was correct, I'm using the yellow LED because the yellow LED was the one that switched immediately from yellow to red. That's kind of just like the logic that was behind my choice and my measurement. But if I quickly, so it is hard to see, I know. So I'll click this one because it's a little bit clear. It's not on the black line. Oh, sorry. So it's this one. Okay, so 17. So if I get my calculator out, 17.70853. Okay, so that's the first, and I define my interval to be this, the high when it's rising, and that's 17.20852. So if I subtract that from this, 17.20852, and you can see that it's approximately exactly 0.5 seconds. I'm sorry, approximately 0.5 seconds. So yeah, so that that kind of shows that the numbers that I used in my SysTick weight 500 ms were correct. It does output a 0.5 second delay for each light. Yeah, so now I just have to load this onto my TIVA board, and so my next video will be me showing that the lights are flipped. So here I'm gonna load quickly load the changes that I made to the file onto the TIVA board. So I build this because these zero errors and 0 warnings onto the board. Load this onto the board, and it does load successfully. The next clip you'll. Okay, so I did just load the files and the changes onto the board. So I click reset. So the light's currently off. Click reset, turns on. Okay, and the switches are in the off state, so all I have to do now is first south, and we'll see go to green, flip that off, flip on west. You can see that slight delay there. It's a 0.5 second delay, and then I flip south back on, and there it does seem to be 0.5 seconds. It seems faster than 1 second, that's for sure. But yeah, so all the files loaded up, and this is the change of 500 milliseconds or 0.5 seconds. It seems to be working.